Have you ever wondered who first pondered the concept of numbers and how they came to be? Our story begins in the Paleolithic era, a time when early humans used tally marks etched into bones to keep track of time. These rudimentary marks were the first inkling of the intricate world of mathematics we now know. Fast forward to the ancient Babylonians. They added another layer of complexity, developing a sexagesimal or base 60 number system. From tracking time to mapping the stars, this system became the cornerstone of their advanced civilization. Meanwhile, the ancient Egyptians were making their own strides. They used hieroglyphs to represent mathematical concepts, giving birth to one of the earliest known written numerical systems. Mathematics was no longer just about counting. It began to represent a universal language, a way to understand and quantify the world around us. Thus began our mathematical journey, as humans started to explore patterns and quantities. Moving forward in time, we delve into the world of shapes and space, the birth of geometry. Enter Euclid, an ancient Greek mathematician whose work in the field was nothing short of groundbreaking. His magnum opus, Elements, is a 13-volume series that systematically presents the principles of geometry, starting with the most basic definitions, postulates, and propositions. Talk about thorough, right? Euclid's Elements wasn't just a mathematical treatise, it was a revolution. It introduced us to the concept of mathematical proof, a method to derive truths from basic principles through logical reasoning. This concept became the very bedrock of mathematical thought. Euclid's work also explored the properties of prime numbers, the geometry of spheres, cones, and cylinders, and even delved into the mysterious world of irrational numbers. All of these concepts, first presented in Elements, still echo in classrooms and textbooks across the world today. Euclid's work laid the groundwork for centuries of mathematical exploration to come. From Euclid's geometry, we venture into the golden age of Islamic mathematics. This remarkable era was illuminated by the brilliance of scholars such as Al-Khwarizmi, whose work continues to shape the world of numbers we navigate today. Al-Khwarizmi was a polymath, but his most lasting contributions were in the field of mathematics. He introduced the concept of algebra, a cornerstone of modern mathematics, brilliantly melding logic and calculations. His book, The Compendious Book on Calculation by Completion and Balancing, laid the groundwork for algebraic equations, providing a systematic approach to solving linear and quadratic equations. Furthermore, Al-Khwarizmi's work on algorithms revolutionized computing. The very term algorithm is derived from his name, a testament to his profound influence. His methods of calculation introduced a new way to solve problems, setting the stage for the development of future computing and information processing. Al-Khwarizmi's contributions forever changed the way we approach mathematical problems. As we continue our journey, we enter the Renaissance, a time of great revival and innovation in mathematics. This period was marked by the contributions of two extraordinary minds, Leonardo da Vinci and Fibonacci. Leonardo da Vinci, the quintessential Renaissance man, used mathematics to bring his art to life. From the precise proportions in The Last Supper to the intricate geometrical shapes in Vitruvian Man, Da Vinci's work is a testament to the harmony of art and mathematics. His mathematical principles continue to inspire and influence artists today. Then we have Fibonacci, the mathematician who introduced the West to the Hindu-Arabic numeral system. But Fibonacci's most famous contribution is undoubtedly the Fibonacci sequence, a series where each number is the sum of the two preceding ones. This sequence not only holds mathematical significance, but also beautifully manifests in nature and art. The Renaissance was indeed a time of rebirth for mathematics. Let's now turn our gaze to the East, to the remarkable contributions of ancient Indian mathematicians. In the cradle of civilization, two figures stand out for their exceptional contributions: Aryabhata and Brahmagupta. Aryabhata, a mathematician and astronomer, was among the first to propose that the Earth rotates on its axis. But his real contribution to mathematics was the concept of zero. Yes, the number we often take for granted, the very essence of nothingness, was birthed in the mind of this ancient Indian mathematician. Then we have Brahmagupta, another towering figure in the annals of mathematical history. He's known for his work on what we now call integer solutions, but perhaps his most significant contribution was his understanding of negative numbers and zero. Brahmagupta was one of the first to treat zero and negative numbers as valid quantities in mathematical operations, paving the way for the complex calculations we perform today. The foundations laid by these ancient Indian mathematicians continue to resonate in our mathematical understanding today. Next, we step into the Enlightenment Era, a time of rapid progress and revolutionary ideas. This period, spanning the 17th and 18th centuries, was an age of reason and scientific discovery. But for our purposes, it was the stage for one of the greatest leaps in mathematical understanding, the development of calculus. Two brilliant minds, Isaac Newton and Gottfried Wilhelm Leibniz, independently arrived at the foundations of this new branch of mathematics. Newton, an English physicist and mathematician, used calculus to formulate his laws of motion and universal gravitation. Meanwhile, across the Channel, Leibniz, a German polymath, was also weaving the threads of calculus, creating a notation system that we still use today. Their work, while rooted in the practical problems of their time, laid the groundwork for a mathematical revolution. Calculus gave us the tools to describe change and motion, to understand the shapes of curves and the volumes of solids, to explore the infinite and the infinitesimal. This era truly marked a turning point, with the advent of calculus opening up new realms of mathematical exploration. As we approach the modern era, let's shine a light on the women who overcame barriers to leave their mark on mathematics. Ada Lovelace, a name synonymous with brilliance, defied the norms of her time. Despite living in an era when women were discouraged from pursuing the sciences, Lovelace's work laid the groundwork for modern computing. Her notes on Charles Babbage's analytical engine are recognized as the world's first computer program. Turning the pages of history, we find Emmy Noether, a mathematician whose name echoes through the corridors of theoretical physics. Despite facing immense professional obstacles, Noether revolutionized the field of algebra and left a lasting impact on theoretical physics. Her theorem, Noether's theorem, is a fundamental part of our understanding of the universe. These women not only broke barriers, but also made significant contributions that shaped the course of mathematical history. Now let's delve into the 20th century, a time of great change and innovation in mathematics. The 20th century was a period of unprecedented progress in mathematics, marked by the emergence of new concepts and theories. Among the most influential of these was Gödel's incompleteness theorems, introduced by the Austrian logician Kurt Gödel in the early 1930s. These theorems shook the foundations of mathematics, revealing that within any given system, there will always be statements that cannot be proven or disproven. This meant that mathematics, as we knew it, was incomplete, and perhaps always would be. It was a groundbreaking revelation, one that forced mathematicians to reevaluate their understanding of logic and truth. Yet while Gödel was transforming the world of theoretical mathematics, another revolution was taking place, the advent of the digital age. From the first mechanical computing devices to the development of modern computers, the 20th century saw dramatic advancements in technology. These innovations had a profound impact on mathematics. Calculations that once took days or even weeks could now be completed in mere seconds. This technological leap not only made mathematics more accessible, but it also opened the door for new areas of study, such as computer science and information theory. But the digital age did more than just speed up calculations. It fundamentally changed the way we approach mathematics. With the ability to process large amounts of data quickly, mathematicians could tackle complex problems that were previously out of reach. They could simulate intricate systems, model unpredictable phenomena, and explore the vast, uncharted territories of mathematical theory. The 20th century was a time of great change, but it was also a time of great innovation. From Gödel's incompleteness theorems to the advent of the digital age, this era reshaped the landscape of mathematics, pushing the boundaries of what was possible and expanding our understanding of the universe. The 20th century marked a new era of mathematical exploration, one that continues to inspire and challenge us today. Finally, let's explore the challenges that contemporary mathematicians face today. We now stand on the brink of a new mathematical frontier, defined by 7 unsolved riddles known as the Millennium Prize problems. These complex mathematical conundrums, posed by the Clay Mathematics Institute at the dawn of the 21st century, represent the cutting edge of mathematical thought. Each problem, whether it's the Riemann hypothesis with its implications for prime number distribution or the Navier-Stokes equations that govern fluid dynamics, offers a tantalizing challenge and a promise of $1 million reward. Mathematicians around the world are striving to unlock these enigmatic puzzles, pushing the boundaries of human knowledge and understanding. Yet these problems are more than just intellectual exercises. Their solutions could have profound impacts across multiple disciplines, from physics to computer science, and potentially even redefine our understanding of the universe. As we continue to push the boundaries of mathematical knowledge, who knows what discoveries lie ahead? Stay curious and keep exploring.